A fluid flowing past an object imparts a force, called drag, to the object. One thing to keep in mind, by the way, drag also applies to objects moving through fluids. Drag is a phenomenon of the relative motion of fluids and objects. Fluids can have both inertia and viscosity, and this means that there are two different kinds of drag. First, there's drag that's imparted to the change of fluid velocity that results whenever fluid flows around an object. This is known as inertial drag. The second form comes from the transfer of momentum through viscosity, and this is known as viscous drag. Objects moving through fluids experience both kinds of drag, but which drag is more important depends upon the Reynolds number. At high Reynolds number, where inertial forces dominate, it will be inertial drag that dominates. At low Reynolds number, where viscous forces dominate, it will be viscous drag that dominates. At Reynolds numbers in between, drag will be a mix of both inertial and viscous drags. See how handy the Reynolds number is? As you watch the lectures to follow, I want you to keep three things in mind. First, why does drag arise from either change of momentum or viscosity, and how is each form of drag influenced by size and shape of the object? Second, what is the relationship between these different forms of drag and size and shape of objects in fluids? How can these relationships be quantified using measures such as the Reynolds number? And most importantly, what does variation of drag and Reynolds number signify for the interaction of objects with fluids? Third, how can unusual behaviors like parachute locomotion or ballooning locomotion be understood in terms of the different forms of drag? And don't worry, we'll define these terms as they come up.